Hello Gators, this is lesson 3.2, Implicit Differentiation. So far we've been working with functions that we call explicit. It's where y can be described in terms of another variable x. But sometimes there's functions that, especially this one, that can't be described like that. We can't really solve for y. So how do we do those kinds of problems? And let's go ahead and first take a look at explicit and implicit and see if we can use the chain rule to help us find the derivative. Over here, the derivative of x we know is 1. You can think of it as dx dx, and then with the same things dx dx, we say it's 1. Over here, we're taking the derivative of y with respect to x. So we can think of it as dy dx. Just like over here, we wrote an x in the numerator because we had an x. We're going to put a y in the numerator because we have a y. Over here, we know the answer is when we take the chain rule, we know that we take the derivative of the outside, 2x, and we don't normally do this, but you could use kind of the chain rule and say dx dx. And then that becomes a 1, and we really just say 2x. Going over here to this side, let's think of it the same way. Let's use the chain rule. The outside function is the squaring, so this is 2y. And then we want to take the derivative of the inside function, which is taking the derivative of y, which we've decided is what we say dy dx. Let's go over here. This is the derivative of e, which is itself. And then you're going to use the chain rule to take the derivative of the inside function, which is 5. We don't usually write it, but we could think dx dx. And normally this doesn't get written, and we just write 5 e to the 5x. But over here where there is a y, it's going to be itself. We are still going to take the chain rule here. We're going to take the derivative of the inside function, which is going to be 5, and the derivative of y is dy dx. So here's the difference between in terms of x and in terms of y. All right, so what are the steps in using implicit differentiation? So here's our relation, and we have y's and x's all involved. Well, the first step is to take the derivative, and each time the derivative of y is involved, you're going to write dy dx. So this is going to be 2y times dy dx. And now we're taking the derivative with respect to x, so this one is going to be 15x squared equals, and then this is going to be 3 dy dx. We are going to, step 2, gather all the terms on one side. Left side is preferable, but you don't have to. So this is going to be 2y dy dx. And I'm going to bring this to this side, minus 3 dy dx. And everything else that doesn't have a dy dx, I'm going to bring on this side, 15x squared. I'm going to factor out a dy dx. So dy dx, and then when I pull that out, that'll be a 2y minus 3 equals 15x squared. Now we're going to solve for dy dx, which means we're going to divide both sides. We're going to divide this side by 2y minus 3, and we're going to divide this side by 2y minus 3. And so dy dx, our derivative, is going to be look a little bit more complicated because the formula will have x's and y's in it, and we'll need the value of x and the value of y to find the slope. All right, let's go ahead and practice one more time. I'm going to find dy dx. So this is everywhere there's a y, remember that you are going to have a dy dx. And then the derivative of this next term is minus 2. And then that's going to be 4x cubed. And I have a y, so plus 2 dy dx. I'm going to bring all the dy dx's to one side. and that'll be minus 2 dy dx. I'm going to move everything else to the other side. 4x cubed plus 2. I'm going to factor out a dy dx, and this will be 3y squared minus 2 equals 4x cubed plus 2, and then I'm going to solve for a dy dx. And my derivative formula is going to have x's and y's. So when I want to find the slope, I will have to have both the x part of the point and the y part of the point. Okay, let's find the equation of the tangent line for this circle at x is equal to 1. So here's 1. We want to find the slope of this line and this line. Let me go ahead and put the point 1 in, and let me solve for y. So then this will be y squared is equal to 3. So y is equal to plus or minus root 3. So this point is actually the point 1 comma root 3, and this is the point 1 comma negative root 3. Now I already went ahead and found the derivative, and here it is. And so now I want to find the slope over here for this particular line. So for the point 1 comma root 3, I want to find the slope. So dy dx is equal to negative 1 over root 3. That's my slope. So now I can write the equation of the line. Y minus root 3 equals negative 1 over root 3 times x minus 1. And this is the slope for this line right here. Now I'm going to use my other point, and I'm going to substitute it into my slope formula, which is the derivative, and our x is negative 1, and our y is negative root 3, which means I'm going to have a 1 over root 3, a positive slope. So now I can write my equation, and that'll be my equation. And this equation represents that line right there. Okay, horizontal and vertical lines. We should be able to find these. Now remember, a horizontal line is when the derivative is 0. That's going to be a horizontal line. And vertical lines are when the slope is up and down, which is undefined. I went ahead and used implicit differentiation, and I ended up getting my derivative right here. So how is this going to help me find a horizontal tangent? Horizontal tangent is when the derivative is 0. The only time the derivative will be 0 is if the numerator is 0. So I'm going to set negative 3x equal to 0, and therefore x is equal to 0. I know that at that point, x equal to 0, I'm going to have a horizontal line. But horizontal lines look like this, y equals. So I need to know what the y is at that point. So I'm going to substitute 0 into my equation. 3 times 0 squared plus 2y squared equals 16. So this will be y squared is equal to 8. And so y is equal to plus or minus root 8. So when y is plus or minus root 8, I am going to have my horizontal line. That is a horizontal line. It's occurring when x is equal to 0. X equal to 0 will force the slope to be 0. Now I want to find all vertical tangents. Now vertical tangents are when it's undefined, and now I'm going to look at the denominator. Now vertical tangents always are x equal. So I want to find my x part of my point, but verticals mean that the denominator ended up being 0. So now I want to look at it in the relationship when y is equal to 0. So 3x squared plus 2 times 0 squared is equal to 16. So 3x squared is equal to 16. X squared is equal to 16 over 3, or x is equal to plus or minus 4 over root 3. These are the places that's going to force the y to be 0. So my vertical lines will be at plus or minus 4 over root 3. So I have to give the vertical lines.